Thank you everyone for coming by for the TMACOG 2021 Water Wastewater Training Seminar. Just want to let everyone know that we'll be starting about 12 o'clock and providing information on how to get all of your credits and kind of what the agenda is going to be for today. So just for now, we're going to allow a few minutes at the beginning to allow for today's webinar to make sure everyone has time to get connected and address any technical issues. And I'd also remind you that in order to receive the operator credits, each attendee must register separately for the webinar. And as I mentioned before, we'll give some more time to allow people to get in, and then we'll start with the agenda for today. Hello, everyone. Just wanted to let you know that we're going to provide just another 2-3 minutes to allow for people to sign in and get ready for the webinar. And then we'll start with an overview of what we'll be going through today and move on to the presentations. So we'll provide just a couple more minutes and then we'll get everything rolling. Hello, everyone. I think it's about time where people have had time to log in and get ready for this. So we're going to go ahead and get started with the overview of today's presentations and how these webinars are going to work. So thank you, everyone, for attending TMACOG's water and wastewater operator training for our second year of having a web-based format. I'm Matt Kennedy, a water quality planner at TMACOG, and I'm joined by two other TMACOG water quality staff, Kari Gerwin and Sarah Geyer. Let me change the Kari and Sarah will be administering the polls and taking questions for the speakers. I'd like to give a big thank you to Jones and Henry Engineers for sponsorship once again for this year's webinar series, and to our presenters for their time in preparing this valuable training. Today's agenda will include presentations on scum handling by Dan Miller and of Jones and Henry Engineers, and water management planning for a Louisville MSD by Rich Atoulikian with HDR. Now, before we get started, I just want to provide a quick overview of this webinar format. All attendees will be muted, but we encourage you to participate in the discussion by using the question function. You can find this in your webinar toolbar. Any questions that are not answered during the webinar will be addressed following that. You'll be able to participate, or you will be asked to participate in a total of 6 polls during this webinar. There'll be 3 in each of the presentations. It's important that you participate in these polls because they help our presenters get to know you, and they count towards your webinar participation score in order to qualify through the Ohio EPA to get those contact hours. More on this participation score in a moment, and you'll be asked to participate in a survey at the end of the webinar as well. This is also a mandatory component of the participation score. Now, Sarah will be launching a test poll so that you have an opportunity to try it out before the presentation begins. And if Sarah, you could launch that poll. And when we do these polls, we'll provide a question to you'll have about 45 seconds to answer, and during that time, we'll be asking questions to our presenters to provide even more information during this time. All right, and then we'll leave this one a little bit shorter since this is just a test. Sarah, if you could close the poll, and then from what I can see right now, it's like we have mostly water and wastewater operators, which is good. I mean, that's really the point of what we're trying to do for these, is to get those contact hours and really provide an opportunity for everyone to get continuing education. Now, to go over some of the important information about the operator contact hours, today's webinar has been approved by Ohio EPA for 2 wastewater operator contact hours, 1 for each presentation. And in order to provide operator contact hours, Ohio EPA requires us to monitor attendance and participation. So in order to receive these hours, you must have the webinar as your active screen for at least 90% of the time for this training. And this means that you cannot use other apps or windows during the webinar. You must participate in 2 of the 3 GoToWebinar polls that will be in each presentation. However, your answers will not be graded, and accuracy does not count towards your participation score. Immediately following the webinar and before you log out, you will be asked to participate in a mandatory survey, and this survey also counts towards your participation score. Any technology issues such as loss of Wi-Fi will not change these participation requirements. If you lose your connection, please try to reconnect as soon as possible. Today's webinar will also include 2 presentations with a 5-minute break in between these presentations. And during that break, please do not log out of the webinar. And with these announcements out of the way, I'd like to introduce our first speaker. Dan Miller received his BSc from the University of Toledo and is a registered PE in Ohio and Michigan. Currently, he is working as the Director of Wastewater at Jones & Henry Engineers, where he is the designer or project manager on a number of wastewater projects. Mr. Miller has spent 39 years in the wastewater industry, 35 years at Jones & Henry, and 4 years at Pelton Environmental Products. He has presented previously at the WEF National Conference and state WEF conferences in Ohio, Michigan, and Indiana. He is also the winner of an Indiana ACEC Honor Award for the Class A Biosolids project in Carmel, Indiana, and an Ohio ACEC Honor Award for the dewatering work in North Baltimore, Ohio. And now I will transfer over presentation for Dan Miller to take it away.
Okay, so can everybody hear me? I'm hoping yes. So we're going to talk about scum handling. I appreciate Matt and Carrie and Sarah for having me on. We're going to talk about scum handling here for the first 45 minutes to an hour. We do a lot of pumping around a wastewater treatment plant, mostly sludges, return and wastewater or waste sludge. So, you know, scum is really a different animal than the other ones. And so that's what we're going to try to focus on today. And I'm just trying. So the unusual characteristics of scum, and I'll stop right there. You know, unusual. What does that mean? It's kind of like a blind date. You know, he or she is very cute, but they're a bit unusual. So that's something that we got to kind of cross over right from the beginning, which may adversely affect. Again, the word adversely is kind of a thrown out there real fast and say, so now you have two kind of keywords, unusual and adversely. And adversely can be very insignificant or could be really very significant. Affect pumping, piping, sludge handling, and disposal, and should be recognized in the design. Provisions. So that's kind of what we're going to talk a little bit about today. What kind of provisions are we going to make for handling of scum? And what are some of the design criteria that are going to go into some of those provisions that we need to make? Shall be made to remove scum and direct to the sludge treatment process. You know, that's a two-way street there. Some people do take their scum directly to sludge treatment. Others take it to some form of disposal. They like to actually keep it out of the sludge treatment process, although there's benefits to having it in there. Others have found that it kind of gums up the work sometimes, so they just rather get rid of it right away. And then the last line is other special provisions for disposal may be necessary. Special provisions, you know, what might those be? Well, again, taking it maybe straight to disposal and getting out of the process. So again, MOP 8 really recognizes scum handling to be kind of out of the realm of what we normally deal with at a wastewater treatment plant. So, you know, scum removal and management, why is it important? First of all, if you get a lot of it at your treatment plant, you're going to increase your organic loads going to your activated sludge system. So you have to account for those loads. Now, when I talk about increasing your organic loads, I'm usually talking about a location that has a food industry or some large scum grease loads that will make it to the wastewater plant in order to increase your organic load. Operational issues, odors, you know, they increase the odors around the plant, especially in the locations where you're accumulating the scum and the grease and whatnot. So I'll kind of call it, they're kind of localized odors, manholes that you may be using as a scum pit or channels at the wastewater treatment plant on your primary tanks. So from an overall standpoint, there are odors being generated and they're just adding to the overall odors at the plant. Visual blight. You know, and when we talk about a wastewater plant, you know, visual blight, how critical is it or how important is it? I really look at operators, and you guys take care of your plants very well, and you like to kind of keep them clean. This is your place to work and where you spend, you know, the majority of your time and day. So having grease balls floating around the primary tanks or floating around inside the channels, it's just not very appealing to look at, and you don't want it to occur, or you want to get rid of them. As you can see in the photo that, you know, it really, they can plug up lines and increase the head losses in piping and pumping. And that really turns into a dollar amount. If you think of just a half-inch coating on a 6-inch pipe, now you've reduced it down to a 5-inch inside diameter. And if you have an inch coating, which is still a pretty big opening, 4-inch, but now you increased your piping head losses. So that's a dollar and cents thing. And then, excuse me, and then also in regards to, you know, contributing to pump and valve clogging, which is a maintenance issue if you have areas where you have to clean out a pump or valve problems due to greases and scums. you know, it's a maintenance issue that you don't like to have to handle and don't necessarily want to handle. One other thing that we've seen scum and grease attribute to is really kind of poor performance in a grit system. The grease likes to float smaller grease or grit particles, so it kind of likes to hold on to the small particles and kind of float them through your grit removal systems. And then normally in your aeration tanks, you end up knocking that grease away, and it releases that grit particle for, you know, for settling either in your aeration tanks or maybe in your aerobic digesters. So it's another area that we've seen greases and scum be a problem. As far as quantity and composition, quantity is chiefly going to be determined by your individual plant. Industrial contributors and septage are probably the two biggest increasers in scum quantity and at a plant. Localized in some of the smaller communities, if you have a small university that has a large population or a somewhat significant student population, we see scum being a larger issue there because they have university kitchens there that produce a lot of greases and oils, and you normally have a pretty large restaurant row. But really, the industrial side is where you might get a lot of scum and grease contribution. Also, if you take septage at a wastewater plant, nothing wrong with taking septage. You just have to be ready for what the components of the septage are, and scum and grease are certainly one of them. That's 90% as far as composition. It's volatile, so you can use the volatility in your digester if you have an anaerobic digester and your combined heat and power source. But it's mostly grease and oils, and you can see there it has a rather good BTU value. So again, use that as a fuel would be perfect. We talked a little bit there about, quantity, again, based on your industrial recycle streams at your wastewater treatment plant, how much flow you're recycling. We tend to sometimes just pass scum around the wastewater treatment plant, sort of want to make it just go away. If we ignore it, it'll go away. And if we, spin it around enough, keep sending it around to the headworks, eventually it'll go, it'll get rid of itself, and that's just not the case. How effective are your removal systems? When it comes to your primary tanks, your final tanks, if you have a skimmings tank of some sort, kind of what gets missed in the process. The collection system can deliver big slug loads from certain areas. A lot of those slug loads typically don't make it to the wastewater treatment plant. A lot of them end up at your intermediate pump stations within the system, because that's the first place the scum and greases and oils have a kind of a chance to accumulate and kind of float on top and not be able to get out of that pump station. Collection systems, again, everybody's putting in a grease trap nowadays, and I think communities have gotten a lot better at checking grease traps. I think back in the day we were a little more lax at checking grease traps and making sure restaurants and places are cleaning out their grease traps and taking care of those. And then again, septage receiving, we kind of talked about a little bit in the last slide. So, the questions always come up, is this a large or a small plant process, as far as scum removal or separate scum removal? I would say any plant over 10 MGD in size should certainly be looking at some form of separate scum removal, like a skimmings tank ahead of your primaries of some type to remove scum and greases and oils I think at that size, you're going to get enough material in there to make it worth your while. As I go into medium-sized plants, and I'll say those, 5 MGD, I think you have to start asking those questions. Do I want to take septage, or am I going to take a lot of septage? Some plants simply don't want to take septage, so that's not a question. And do I have a lot of industries in town, food processors especially, that are going to give me a higher level of fats, oils, and greases? And am I willing to accept industries with higher levels of fats, oils, and greases? A normal sewer permits, I think the normal number is around 100 milligrams per liter on your fog. If I have an industry that wants to discharge, 250, am I willing to take that food processor into my plant? Smaller plants, it depends a lot. If you don't have primaries, or with or without primaries, so to speak, you have some separate handling facilities. We're doing smaller plants now that don't have primaries. We'll go right to for example, an SBR or oxidation ditch. They don't, we've done a lot of plants without primaries. So, you may not have any separate scum handling facilities. Again, do you have any large industrial loads? So one thing is that you always have to remember that if you're going to capture it, no matter where you capture it within your scheme, you have to have a reasonable outlet to get rid of it. And so once I capture it, what am I going to do with it? No matter what size plant I am, a 10 MGD or 5, or even a smaller plant. Okay, I'm going to capture it. I know I have a problem. So now how am I going to get rid of it? So I think, we don't have a poll question coming up just yet. A couple more slides. So where should scum be removed in a wastewater treatment plant? So typically at most plants, and I will say 5 MGD or less, they're going to be removed in your primary settling tanks, and that's where the majority of your scum is going to come out. There's a smaller fraction that's taken out in the final clarifiers, but it's a lot smaller. You tend to see, once we get through the aerobic process, that the greases and oils start to break up, start to assimilate themselves. Remember, they're volatile, so if you've taken out a good majority of them in your primary tanks, some of those volatiles can get taken up in the activated sludge. Tighter screening has allowed removal of more grease and scum lately. Now you won't see so much in a 1/4-inch bar screen, which I think a lot of people have gone to these days to certainly meet the biosolids regulations, are down to at least a 1/4-inch bar screen. But as soon as you go to like a punch plate screen or a step screen, or even a smaller opening like an 1/8, then you can allow that screen to mat up. And if you're working the screen off a differential between the inlet and the outlet, you can let a mat build up, and you can pull off scum and grease and oil in that way. And then there's always separate skimmings and scum tanks, and again, or DAFs, that you'll see in a larger, and typically are much larger plants, 10 MGD and larger. And a skimming and scum tank is, I'll say, call it an undersized primary, usually has chain and flights to take the scum off, and some type of rotating scum trough to remove the scum. But that's where scum should normally be removed. The problems become is, where is scum removed? And I think most of you operators out there are aware of this. It ends up at dead-end channels, especially in your primaries and your aeration channels. So, some of that's some of it's avoidable, some of it's not avoidable. We tend to like to, as engineers, we plan for the future. We want to plan for the future. And so we kind of extend our channel sometime out a little past the last opening into a tank. And so that we can connect onto it in the future. We can make, building in the future a little easier. We can prevent some of that by maybe putting in a false wall at that last opening going into a tank, so that everything comes into your channel, goes into your tank. That's really our goal, and I'll show you another slide in the future. And then the other place it tends to accumulate are influent and drain pump stations, or out in your system. You can see, the top of looking down on a pump station here, and all the scum and grease and oils that have accumulated. And normally what happens then, if it accumulates in a channel or in a drain pump station, you guys bring out the vac truck and you vac it out. Is that such a crazy bad system? Nah, not really. I mean, you are capturing it, and you're vectoring it out, and you're getting rid of it. Can we do better? Yep, we can do better. So that's what we're going to talk about a little bit. So here comes the poll question. I will let Sarah do this, but what's the chief component of scum? Solids, rags, oils and grease, none of the above, all the above. So kind of sit here and wait a little bit for your guys' results.
Okay, and we have about 70%, 75% voted now, with about 10 seconds left. Okay, go ahead and close it. All right, and it looks like 79% of people said oils and grease, and then 21% all of the above.
So I would say that we're in the right spot. I would accept kind of either answer, either C or E. So it's kind of a little bit of a trick question there, because you're going to have solids and you're going to have rags in there too. So both answers are good. So we'll keep moving along. So obviously, on the trick side of the question was, you guys have dealt with it before, so you know that solids and rags and everything seem to come in with the, septage loads or your greases and oils. So let's start talking about scum removal mechanisms now. And in primary tanks, if you have rectangular primary tanks, normally you have a full-length skimming tipping trough down at the end of your tank there. And it can be manual, or most of them I see are manual. I have seen automated ones, normally in larger plants where they have many primary tanks. But the manual ones work just as well as the automated ones. You roll the trough down to take in the scum and the greases and oils on top of the tank, and it either goes by gravity to a pump station somewhere, or sometimes it's directly pumped off of each tank. On circular tanks, there's a scum beach, like you see in the picture here. This must be it's got to be a final clarifier, because there's no primary tanks that look that clean, and it looks like I see a lot of algae there, or kind of I don't see a lot of scum there. So it's a picture of a final clarifier too, especially with the brushes being on that. So again, sometimes there's a separate collection manhole. And what I mean by that, it's a manhole where people are making it act like an influent well to a pump station. So we're just going to make us a big manhole, and we're just going to allow, hopefully, grit, and we're going to make a real slow velocity through there and allow the scum and the grease to kind of pop up, and then we'll suck it out in the future. So final tanks, chiefly a scum beach, but they can be full length as well. Same way in primary tanks, you can have full length scum beaches as well. And then there's the skimmings tank that we talked about earlier, that you'd see in a larger plant. Usually a chain and flight collector with a rotating scum trough. So it's a smaller than a primary tank. So you have a much smaller detention time. We're not really trying to gather a lot of primary solids in this tank. We're just really trying to focus on giving a long enough detention time for the greases, oils to pop up and get out of the tank, and then so we can skim them off. I usually here again, you know, it might not be a manual operation. It tends to be an automatic operation for those rotating scum troughs. Scum and beach troughs, you know, when we talk about them, here's a full length trough. Typically, and you can see this one, it's a kind of an odd looking picture is off to the side, but you can see the walkway that's next to it. And really you should have access to that scum trough from the walkway, or the scum beach from the walkway, so you can flush it out and hose it off. So it's important to have a yard hydrant near your clarifier or your primary tank so you can flush it out. In fact, you can see in this particular one, you can actually see some of the scum blocking the openings into that trough. All the trough systems have some form of automatic flushing valves on them, and I would say they all fail. So no matter what kind of toilet valve you may have on the end of your flushing trough, when your mechanism comes around, sooner or later it's going to plug, it's going to get something in it, and it's going to leave itself open, so that you're always flushing water into your trough and putting more water into your plant drainage system. Or on final clarifiers, it's they always seem to grow a little bit of algae on them, and that'll eventually hold them open, and so they'll be flushing constantly as well. So that's why I said put a valve on the discharge, so you can get in there and fix them, and not get your, you know, put some kind of valve on the pipe off the scum beach so you can get in there and fix them, because you're going to have to fix them, clean them off every once in a while. So when we talk about, now we've gotten it, we've captured it, and we're going to, you know, we need to pump this stuff to our scum treatment or some form of treatment, whatever we're using for treatment. Most often I see a chopper pump used, and you know, those can be, there's a lot of chopper pump manufacturers, but typically the word chopper pump you kind of associate with a Vaughan chopper pump. You know, so it's got a little chopper nozzle on our chopper blade on the front there, and an impeller, and they work really well. They'll chop up the materials that are in there, because like you guys said in the poll question, you know, you do get other things in there, solids and plastics and rags. So chopping them up and trying to move them along is important. Recessed impeller pumps, and Wemco is a traditional trade name that you know, you see, and again, there's various manufacturers, but the idea of a recessed impeller pump is that you can see it has a big free passage of solids there in the blue, the one there in the middle of the page. So with the impellers outside the flow path, so it's just kind of generating energy to move the solids through the casing there and out of the pump. And then finally, a progressive cavity pump. I see more, I've seen on pump or on scum. And the idea here with the progressive cavity is you have, again, big wide opening paths to move the material through. It's like a piston style, diaphragm piston style pump. So we're trying to keep the opening paths as big as we can, or chop it up before we get to it. So the larger the opening, the better. On that, you know, on the Penn Valley, it doesn't really matter if those pumps run dry. So other progressive cavity pumps have small openings. You know, a CPEX or a Moino have really kind of small openings where we're pressing the rotor against the stator. So when I talk about some kind of progressive cavity, I'm more looking like a piston pump, even the older style Moino piston pumps that have the big pistons in order to move some scum. As far as our scum transportation lines, okay, now we're pumping it, now we got to move it. You know, if you're moving it by gravity, be sure to kind of slope the bottom of a tank or the manhole in order to kind of make sure we're moving it through the manhole so that we put a nice slope on that manhole, put those benches in there so we can move it right on through a manhole. When we're talking about wet wells and a pumping, you could consider mixing the contents, and I'll talk a little bit later on how Lima mix their contents within their scum wells. And the reason here is to kind of homogenize the material. If you can kind of get it homogenized up, then you got a better chance of kind of bringing your level down lower in your pump station and get those materials out. You know, I know people will lift the bottom float and try to suck that thing all the way out, and it's really hard to even do that when you have a lot of grease and scum on the top. But if it's all mixed up, you got a much better chance of lifting that bottom float on a submersible station and sucking that stuff out when you're throwing some water in that station. In extreme cases, you know, flushing connections or pigging stations, if you're, and again, it might be more of an industrial process that they're handing a lot of greases and oils that they put a separate pig in to pig out the lines that they're using for transport. Clean outs, definitely put clean outs along the way so you can flush them out. Avoid using 90-degree elbows if possible. If you can use 245s, there's certainly a cost there to put 245s in, but you might save yourself some headaches down the road in regards to cleaning it out. And then also glass line piping is really nice for gravity lines, to utilize in gravity systems and even pump systems to help keep your pump lines clean, keep your cost of transport down, especially on longer run lines where if you're going to pump any kind of considerable distance. So as we talk about channels, and you know, we talked a little bit earlier about they accumulate in those dead end corners. So no dead end corners. You know, make that last opening of the tank flow into your particular primary tank, usually where we see those dead end corners. You know, one really important thing that sometimes gets overlooked is, you know, on the tank openings, we always put a slide gate there to you know, be able to close off the tank openings. Sometimes we just don't get that slide gate down up far enough that we allow the opening to be free and clear. And if you don't allow that opening to be free and clear, then that grease and oil and scum that's supposed to be taken out in the primary tanks never makes it into the primary tanks. It's just sitting in that channel ahead of the primaries and accumulating. That's all it does. And again, you guys come out and you'll suck that channel out every 3 months, maybe 6 every yearly, and suck it out with your Vector truck. But if that gate would go all the way to the top, that would go to your removal mechanism in the tank and allow that removal mechanism to take out the scum. Fillets in the corner, and so that if you have some corners, so you don't get stuff accumulating in the corners, that's where grease balls like to form, and they just kind of spin around forever in the corner, and they grow and grow and grow. I'm sure you've all seen grease balls, haven't seen them accumulating in your tanks, and you know, one day it's just a little tiny, you know, 3/4 or 1 inch grease ball, and you know, 6 months from now it's a big old 6-inch grease ball. So fillets in those corners to keep the liquid moving, and then fillets, extend them above the high water level. Sometimes we don't get them up high enough and stuff will just accumulate on top of the fillet. But if we get it above high enough, the high water level, usually to the top of the tank wall, nothing will accumulate on top of that fillet. So just a couple ways to on design consideration on channels. We're going to move now into scum treatment, and what do we do now? So we talked about it, we've captured it, and now we got to treat scum. We got to do something with it now that we captured it. And we talked earlier before, if you're going to catch it, you want to do something with it. So this is a real simple concentrator tank. They can either be stainless steel or carbon steel. Either way works. We've gone a lot to stainless steel these days, so probably be my choice. There's option in these style of skimming tanks, a variable speed skimmer, and adjustable overflow weirs. So that mechanism that's kind of going around in that tank to skim the grease and oil off the top. You can variable speed drive depending on the loads that you have. Normally, I would say a lot of times they're getting to be covered nowadays, or at least have covers with hinges on them so you can kind of see what's going on inside the tank. And then they often discharge directly into a container, or sometimes they can directly discharge into another smaller tank, and that's what this particular one is doing. And you can see that smaller tank has a mixer on it, so it's going to try to homogenize the grease and oil and scum as well. So that's this, you know, and that's kind of this heated batch tank. I don't know how well you can see the photo, but if you look in the upper left-hand part of the photo, you can kind of see a skimmings tank discharging into this homogenized batch tank. There's a mixer on top there, and this tank has a particular heated jacket. And so what we're trying to do is keep everything fluidized real well, heat it so it can further reduce and homogenize itself, put a mixer in there so that you can get it all mixed up, and then pump it to where you need to, either an incinerator or anaerobic digester. You'll steal the heat, or I shouldn't say steal the heat, but the heat on the jacket can come from your incinerator or your anaerobic digester. So you have a low temperature jacket on there just to keep everything, allow yourself to homogenize it, keep it nice and liquid. You've pulled it off now with the skimmings tank, and now you can send it to your digester. The digestion or the breakdown process has already started, so normally you don't have those bad effects of sending a big slug load of material to a digester, and you can get that heating value from the scum that you're looking for your CHP process if you happen to have one at your wastewater plant. One other method of treatment or removal that I've seen once you've captured it is dissolved air flotation. There's a few larger plants that have dissolved air flotation for scum treatment and removal. You don't often see it in smaller plants, but you will see it a lot in larger industrial applications with really high grease loads. So it'll utilize micro bubbles to float the grease and scum to the top and then push it off the end like the simple skimming tank did. So it's a more advanced skimmings tank than the one we previously talked about a few slides back because of those micro bubbles. And because it's more advanced, they usually get more load. You also get some denser particles that are going to settle down at the bottom. So you'll have a bottom skimmer and some way to remove the sludge from the bottom of the tank. So here they would call that the underflow, and you'd have an overflow at the top to take care of your greases and oils as well. So I've seen this at a few plants, mostly smaller plants. They seem to work fairly well. It's called a scum screen. They're externally fed. They're normally pretty small, and a tight weave on these screens, and they can discharge the scum straight into a dumpster like you see here. I want to say that's a picture of Englewood, Detroit, Ohio, but I'm not absolutely certain. And then they have a spray wash to help the scum screen to prevent clogging. So they work fairly well, the ones I've seen and talked to people at smaller plants, and don't hear a lot of complaints. But on the other hand, I don't see a lot of them in service either. So probably where they work well, the operators really like them. So just here's a kind of a little quick video of that scum screen. You can see it's a really tight wedge wire mesh. So one more time through the video. So that on the scum. So on the scum screen there, that material will collect and normally just push out over the top of a weir or get knocked off with a wiping blade. And then the last thing for treatment is, probably the simplest is your old sand drying bed. Most of your plants have a lot of smaller plants have a sand drying bed around. We've typically converted them into part storage or junk storage of some type, or they've been converted into sewer bed dumpings, but they work really well for scum. So if you take your scum line and you dump it directly to your sand drying bed, it gives a plant place for the scum to drain. This one's got a picture of simply just sludge on it, but they work really well. I mean, they give a chance for it to drain out, and then you just come scoop it up with your Bobcat, throw it in the dumpster, and take it to the landfill. So it's usually pretty simple, but works well. Here's poll question number 2. Which of the following forms is not a form of scum treatment? A screen, DAF, a belt press, or a concentrator? So I will let you guys answer the poll question here.
And Dan, while we're waiting for folks to answer that question, I've got a couple questions here for you.
Okay.
The first is, are there items that you should avoid when handling scum?
Ooh, items like, heavy grease loads, coming from at a septage facility or somebody that's just collecting grease traps in a solo tank. That can be really problematic. I'll talk about that a little bit later on, so that you get so much grease coming from grease traps in that load that you really, goes back to that MOB 8 question. You really got to make special provisions to take really, really heavy loads of greases and oils. But other than that, the only thing I can think of, if there's anything that might be harmful to your treatment facility, like, kill the biology within your plant.
Okay, thank you. Sarah, how's that poll coming along?
Looks like we have just about everyone voted, so I will give a few more seconds and then I will go ahead and close it.
All right, well, we'll get to the rest of those questions later on, and I'll encourage everyone, if you've got questions throughout the presentation for Dan or any of our speakers, feel free to enter those into the chat box or the question box, and we will hopefully get to them throughout the presentation or at the end.
Okay, and I'll go ahead and close it. Looks like most answered belt press, and then concentrator is the next most popular answer.
So a belt press would be the one that I didn't talk about there, and maybe the concentrator is a skimmings tank or another way to, or that heated batch tank. So my terminology there may not be as clear as it should have been. So, but the belt press is the kind of answer that we're looking for. So I'm going to talk about Lima's scum handling. This is a project that we did. We recently replaced their primary clarifiers, and Lima takes in a lot of greases and oils, and they take in a lot of septage. And so one of their focuses was on to what are we going to do with the scum and greases and oils that we get from the septage and the industrial loads that we have. So their first facility here, this decant tank, this was their older facility as part of their facility, and I think the new pumps can pump to this decant tank as well. But the decant tank basically takes scum from the older primaries, I believe, and it's a real simple operation. It's hard to see in the picture, but basically you just fill it up, and what makes its way to the top goes over a weir and falls into a dumpster, and is hauled off to the landfill. And in order to help the grease and oils float to the top, there's an air line going down the right hand side of the page with some diffusers on it. And so it's kind of like a little baby DAF, so to speak, a very simple DAF. You know, it doesn't create the micro bubbles that you'd see in a DAF, but the objective is the same. Use air to float the greases and oils and just have them skim off the top. So on their 4 new primaries, they put in the full-length skimmers, and this was a picture that you've seen before. There's that full-length skimmer, and that's the one you can tell it's, you know, the tank at this time's out of service, but you can see that they get a lot of scum and greases and oils as they've actually stuck in between those bars that keep that skimming trough together. So that's all collected, and it heads over to a pump station. And each, I believe, two tanks each feed 1 of 2 separate wet wells. That has 2 Haywood Gordon chopper pumps in this dry well configuration. Again, could be just about anybody's pumps, but a couple of things that I like here in this particular layout. You can see that it has a very short suction line there, so that, you know, you're going to pump greases and oils and scum. You don't want those lines to build up or to be very long. So make it kind of easy on the system. There's a valve right there and a feed line, a water feed line, so we can easily flush that suction line out, so we can back flush the suction line in case it does get plugged. This particular well does have a homogenizing system to try to homogenize the scum and grease within the wet well. And if you guys are familiar with flight pumps, they started this system that has a nozzle that allows the discharge to so that the pump suction is here. I don't know if you can see my mouse or not, and then the pump discharge, and we have a nozzle linear actuator up here, and then we have a nozzle that will change the actuator and kind of mix up the materials within that well to kind of homogenize them while you're pumping it down and get you a chance to get the well completely cleaned out. So it's a pretty simple system. It is manual. It was a selection versus trying to put in some kind of mixer to go in there instead, or to use air to try to mix it up, but air quite often just gets everything to float to the top. So this system was put in to kind of try to mix it up, and so that we could kind of pump it out. So those pumps then feed a new externally fed drum screen in a tank. So see it's 1256, so I'll try to keep it moving along here. It has a compactor on the end there. You can see the bag, so anything that this Scum screen takes out, it goes down goes into the baggie. So you can kind of keep the odors and flies and vermin out away from the Scum. That internally drum screen is basically a basket screen that a lot of you little plants already have that's put into a tank. So what are some of the design details there? It's, all 304 stainless steel construction. It's, tank mounted screen. It's a shafted screw on a 35-degree incline. It has a very tight wedge wire, 0.5 millimeter wedge wire, and then a pretty significant spraying system. So obviously when you're handling greases and oils and scum, you want to be able to spray that screen off so you don't get plugging of the screen. Closed discharge chute and the bagging attachment, and then a booster pump is included to get you a high pressure screens. One thing about the bagging attachments, normally on a standard wastewater screen, same type of screen, I get crazy about the bagging attachments because sometimes you can't see what's in the bag, so that when you try to move the bag around the dumpster, you could get cut by something or poked by something that's not in there. Here, on a more specific system for Scum, I can see it being an advantage of keeping down the odors and everything else. So there it is. There's your simple basket screen that's put into the tank, and we pump into the tank, and we collect the Scum and the grease and oils, and we push it up the transport screw into the compaction zone, along with any other materials that happen to be in there. Again, there's 3 high pressure washing systems on this machine with a booster pump as well. So I believe it boosts up to about 100 PSI or 120 PSI. A normal basket screen, you would see maybe only 60 PSI, or normal plant pressures, probably pretty adequate on a normal wastewater screen, basket screen. But here, when we're going to talk about Scum, greases, and oils, we're going to wash it with a much higher pressure. So finally, poll question 3, before we talk a little bit about how Lima's doing. What's the most critical consideration when handling Scum? Both that it floats and settles. It'll stick to anything. Will contain plastics and foreign materials, or all of the above.
Okay, Dan, I think we've got time to get to another question. Is it possible to have no Scum handling facilities?
Sure. It's possible. If you don't have any primary tanks, and like I said earlier, that we do a lot of treatment plants now without primary tanks. So aerobic digestion, we'll go straight through a screen, and the screen will pick up some of your Scum straight into a orbital or oxidation ditch, or even an SBR, and then off to final clarifiers that only have a Scum beach. And quite frankly, we'll chase that right back to the head of the plant, and hope it comes out. So does it come out? Some does. Does it want to accumulate somewhere? It might. You'll just end up finding where it accumulates.
All right, thank you. Sarah, how are we doing on the poll?
Looks like everyone who voted the last time voted this time, so I will close the poll and we'll look at the results. It's like 94% said all of the above, and then just 6% thought both floats and settles. It's most critical.
You guys are right on it. So I can see I'm getting close to the end of my time here. So how's Lima doing? That's always the question. You know, we go through a design and you wanna know how it works, you know. So they had to relocate the sonic level detector within the unit. So the level detector was underneath the cover on the unit. So due to all that high pressure washing, it was taking its toll on the level detector. It was getting splashed on and material was getting stuck to it. So they were having to open it up and clean it. So what they've done, they cut a hole in the top and basically moved the sonic level detector so they can get at it more easily by putting it above the cover, so to speak, or kind of right at the level of the cover. Something we talked about before, they have plugged it from certain food waste and grease. So where they've taken in a load full of a lot of grease and oils, and so they have plugged it. And that's kind of what we talked about before. You got to be careful of your loads. Sometimes you know, you guys should have a mix, but when you take a load full of just really bad stuff, bad things can happen. And you know, if you've ever worked, I worked in a restaurant a long time ago, and it had grease fryers, and somebody left the nozzle at the bottom of the fryer open one time, and so when the grease all melted, it ended up on the floor. And there's not a whole lot you can do about it right away, other than just wait till it congeals and clean it up with a spatula. So cleanup is difficult when you get big loads of grease anywhere. They're considering adding hot water to some of the sprays. I don't know if they've moved in that direction yet. That's a difficult kind of spot to move into. You know, your objective is I got it in there, I want to get rid of it, I want it to go out the screw. I don't want to kind of, I'll call it, break it up, clean it off, and have it go out the discharge of the unit. I want to collect it. So, because if it goes out the discharge and then recongeals somewhere else, I'm going to be dealing with it with somewhere else. So I don't know if they've added hot water yet, but there was a consideration. It was talked to, and maybe they were only going to do it in one of the spray bars. So other than that, other than the one-time plugging up, and as I understand, and the moving of the level detector, it's worked really well. So with that, I'll open it up to questions.
Okay, thanks, Dan. Yeah, a couple of questions here. So over time, has the need for scum handling become greater or lesser at wastewater treatment plants?
That's a good question. You know, it's kind of dependent upon the neighborhood, so to speak. You'll ask me why, and a lot of departments have told me if I have a neighborhood with a lot of apartments, then it seems like the scum and grease loads can be more. And when I have more homes, it could be less. But in general, nowadays we stuff everything down that garbage disposal, including whatever grease has done. So I would say probably, you know, it might be a little less because we don't like to use greases and oils as much anymore. But on the other hand, everything goes down the garbage disposal, and my mom used to collect the grease in a can and throw it away. So I don't think a lot of people do that very often. So we'll call it hasn't gone up and down. How about that?
Well, we have some other related questions just regarding the sources of scum. So have any new consumer products changed how wastewater treatment plants have to handle scums?
I don't think so. Not that I'm aware of. As far as the consumer products side, I would say no. I don't hear of anyone complaining because they're getting a lot more scum, oil, and grease from any industry in town, other than, again, chiefly food processors.
Okay. Then on the industrial side, has industrial pretreatment, I guess, effectively removed the need for scum treatment on the industrial side? So from the
Yeah, it helps tremendously. I mean, again, most sewer ordinances, I think, are around 100 milligrams per liter for FOG, and that's the pre-treatment standard. And if you go over that, you know, you're going to get fined for that. So most industries, you know, obviously they're avoiding kind of penalties on their wastewater treatment. And I'll say on the other hand, though, you know, everybody wants to invite industry into their town too. So, you know, can we compensate for people that have higher than 100 FOG? Or will we take those places that might discharge us? You just have to be ready for it and make the provisions for it. But yes, in general, pre-treatment, certainly on a food processor, is almost absolutely necessary.
Okay, and one last question. You talked a bit about the design considerations. Are these design considerations dependent on the size of the facility or the flow into the facility?
Yeah, for sure. I think earlier we talked about large facilities and medium and facility. You know, as you get smaller and smaller, the loads obviously are less and less. And I think you had an earlier question, do I even need it? If you have primary tanks, I would say yes, you should have some way to get rid of the scum that you collect on your primary tanks on a small facility. Then medium and larger facilities, certainly anything over 10 MGD should, or most facilities that we work on over 10 MGD have some form of separate scum removal facility. I know Toledo has separate skimmings tanks that they have to take off scum before it gets to their primary tanks. Medium size, that's really kind of a call maybe for what your industrial base kind of look like. If you're dry packaging, you know, maybe you don't need a separate skimmings tank. But if, again, if you have a lot of industrial contributions that have greases and oils, skimming tank may be something that you want to consider.
Okay. And just one last question for me, because I'm curious, how, you know, we hear a lot about disposable flushable wipes, and I know those aren't necessarily considered scum, but how does that interact with scum handling at facilities?
And anytime, yeah, and all the operators already know, anytime you have disposable wipes in a large quantity coming into the plant, they're gonna mess up and gum up the works for everything. So, you know, again, disposable wipes are really a headache. How we ever let the term flushable come into the wastewater lexicon as being okay is beyond me. You know, gosh sakes, flushable's okay, and it just drives me insane when I see that the woman cleaning the toilet or the man cleaning the toilet. I'm not saying only the ladies clean the toilets. And then they pop off that little head of that brush and it goes whoosh, away it goes. Well, it goes down to the operators that are all sitting here and they got to get it out somewhere along the line. And just on that note, there's actually a national organization, and I forget the name of it, for disposable wipes. So there are criteria for what actually makes it a disposable wipe, one you should be able to flush or a flushable wipe, and one that's just a disposable wipe. Just because it's disposable doesn't make it flushable. And you can find stuff, highlights on YouTube and stuff where you see an actual flushable wipe kind of disintegrate within a beaker with a spinning magnetic stirrer, where a flushable wipe just keeps going round and round and round. So yeah, the operators all know about flushable wipes and disposable wipes. So again, how we let that term flushable ever get in besides toilet paper, I don't know.
Well, thank you for that. And that's why I asked that question. It sounds like there's probably a need for a public outreach campaign, and I'm sure there are some of those out there that we can share.
Well, there probably is, but I can tell you my brother-in-law will never get rid of his flushable wipes. He just loves them. So There you go. I think the people that started using them prefer them over toilet paper. So no matter what we say, they may continue to use them. So.
Well, there may be no going back.
That's right.
I'm going to hand it over to Matt to wrap this up. Thank you, Dan.
Thanks, everybody.
Yeah, thank you so much, Dan, for presenting. Just wanted to let everyone know that we're now going to take a 5-minute break. And with that, so we'll have everyone come back about 1:15, 1:16, or we'll get started about 1:16 to allow everyone time to be able to take a quick break here. One of the things that we want to notice is don't log out of the webinar and don't leave the webinar screen so that it doesn't mess with some of your performance scores. So thank you very much, everyone, and we'll return here soon. All right, well, after that 5-minute break, I'd like to present our second speaker to begin for the second part of today's webinar training. Rich Atoulikian received his bachelor's and master's degrees from Cleveland State University. He has over 40 years in experience of, apologize for that. He has over 40 years of experience in the environmental engineering field, providing technical expertise and project management to clients across the Northeast US and the Midwest. Rich is a registered professional engineer in Ohio and many other states as well. His technical background includes wastewater collection and treatment, water treatment and distribution. In addition to Louisville, Kentucky MSD, he has led energy management studies for DC Water, Harrisburg Capital Region Water, the Atlanta Department of Watersheds, and Aurora, Colorado Water. And with that, I will hand over the presentation to Rich.
Okay, hello everybody. Hey, can you see my screen? Should say HDR with a white screen.
It's currently split where right now you're on presentation mode, where if you want to go to display settings up at the top,
The
to
top
the
of
left side. Yep, just go to the left side of where you are right now.
here.
Because right now we just see the notes
Okay.
side.
Okay, so where do I need to go?
On the section where it's the screen where you have the two slides next to each other.
Oh, display settings. Okay, swap.
Yes, sir.
Okay, all right. Sorry about that, everybody.
No problem, and we can see it just fine now. You can take it away.
Okay, that's where the 44 years and sometimes technology limited comes from. I grew up or started my career when slide rules were still in vogue. So anyway, good afternoon, everybody. My name's Rich Atoulikian, and today we're going to talk about an energy and water management plan that we did and I led for Louisville MSD in Kentucky at their Morris Foreman Water Quality Treatment Center. And as we get into this, and that's me, as we get into this, we're going to talk about first the project driver. We'll talk a little bit about the plant because I know we're all interested in knowing what the processes are. We'll talk about our approach to energy and water management. We'll talk about a few of the ECMs or energy conservation measures that we identified as we perform this study, and then we'll talk about the path forward from there. And two things, a little hint, remember what ECM stands for later on. And also the process that we're going to talk about is scalable. So Morris Foreman, you will see, is a pretty large plant, but I've also used this process for much smaller plants down to 3 MGD or so on water and wastewater facilities. So let's talk about the project driver. Louisville embarked upon a One Water initiative back in 2012. It was driven by the mayor at the time, who said that he wanted to find energy savings across the enterprise, both with Louisville MSD on the wastewater side and Louisville Water on the water side. He also wanted to look at the fleet, IT, HR, procurement, et cetera, the other things that are listed up there, and look for synergies between the two departments. So his goal was to save at least $800,000 to $900,000 a year in energy. MSD actually broadened that a little bit to energy and water, and this is, again, their largest treatment plant. In fact, I think Morris Foreman might be the largest plant in the state of Kentucky, if I'm not mistaken. So they went through a two-step process. They shortlisted the 3 firms, and we were fortunate enough, HDR was, to be selected to deliver this project for them. This is an aerial of the Morris Foreman facility here. It sits right on the Ohio River. And a little bit of background on it. As I mentioned, it's Louisville's largest facility. It treats combined flows. Average daily flow is 100 mgd, dry weather capacity is 120, and then under very high flow conditions, wet weather capacity is 350. And they basically treat all flow with primary and disinfection at 350, and then up to about 250, I think, on the biological side. They have a permitted wet weather bypass, and they actually accept and treat biosolids from 5 other regional facilities that MSD owns and operates. So their liquid stream process is pretty typical, except for 2 things. They had biofilters, which they decided to keep in place when they added a high purity oxygen system as part of one of their expansions, perhaps 20, 25 years or so ago. So they really have 2 different types of biological treatment, and we're going to talk about that a little bit more as we move through the presentation. And because they're on the river, there's times when the river stage is up when they have to pump their final effluent. On the solid stream side, previous presenter talked about dissolved air flotation. They have DAFs, they have anaerobic digesters. They had at the time of the study centrifuges, drum dryers, thermal oxidizers, and they basically produced a product called Louisville Green, which is a fertilizer blend, similar basically other than a name to mill organite that we're all familiar with. And really, since this project was completed, MSD decided to move forward with a thermal hydrolysis process. Canby is one of the manufacturers, you probably recognize the name, and remove the digesters and dryers. So we're going to do our first polling question right now, and that is, what was the primary driver for Louisville MSD's embarking on a water and energy management study? Was it to make the utility more resilient, to comply with the mayor's initiative? They just had some money left over and it seemed like a good idea at the time, or it was something that the plant staff wanted to try? And I guess I need to...
Okay, Rich, while we are having participants answer those questions, I've got a question for you.
Sure.
Are these energy and management plans scalable for different size facilities?
They very much are, and they're really also, I would say, fit for purpose. So, I've seen some utilities spend, a few $100,000 to really do a very detailed study and actually come up with concept designs of the recommendations. And we've also done these for other utilities who say, well, we want to spend less than $100,000 and come up with really a prioritized list of things to do, and then we'll develop them ourselves, or we'll put out separate projects to implement them. So yes, they are very much scalable.
All right, great. Clara, how's our poll coming along?
We have a few last that have answered this time. If anyone still would like to answer, I'll leave the poll open for just a few more seconds, and then we will take a look at the results. All right. Oh, pretty close between the first 2 answers, between to make the utility more resilient and to comply with the mayor's initiative.
Right, and really, in this case, it was to comply with the mayor's initiative, but there are a number of utilities that have implemented this. DC Water is one that I've worked for because they did want to be more resilient, and they wanted to, reduce their greenhouse gas emissions. So, good answers. Let's talk a little bit now about our approach. So as I mentioned, the goal of this project really was to implement cost-effective improvements at this facility to significantly reduce energy and water consumption while maintaining effluent water quality standards. And that's important because there are certain firms that may come in and offer to do energy savings, but if they don't have a water and wastewater background, they don't understand, operations side and the importance, the criticalness of operations having to meet their permit requirements, and the reliability that goes along with that, it could fall short. So we spend a lot of time talking to operations as we do this to make sure we understand what's critical to them in terms of how they operate the process so that there's no chance of compromising their NPDES permit. There's 3 basic steps that we follow when we do these, and again, it's scalable. The first one is benchmarking. The second one is to identify ECMs and prioritize them, and then last is to develop the report and a sustainable program. And I can't say this enough, that collaboration with the utility is critical. A successful project leverages the knowledge and experience of plant operations and maintenance staff and their engineering and construction personnel with what a firm like ours brings to the table. So under the benchmarking step, we do things like look at where the usage is and how much it is of energy and water. We look at utility bills. We look at process operation. We walk the plant with the operators process by process to gain an understanding of, as I said, what's important to them. On this particular one, there was not a lot of electrical submetering data available, so we actually installed submeters to get a better understanding of where energy was used. And we basically then established the baseline. So what you see here, this is from the WEF Energy Conservation in Water and Wastewater Manual of Practice number 32. And it's for a typical, whatever typical means, advanced wastewater treatment plant. This shows that aeration consumes about 54% of the energy, which is pretty common. I mean, I think we all kind of know that aeration has big blowers and big motors. In their typical plant, they had anaerobic digestion. That was another use as well, in wastewater pumping. So I provide this just for your information. Really, what we did was we developed one of those for this plant, and that's typically what we will do, is to be able to look at where energy is used and water is consumed at the facilities that we're evaluating. So when we started this, and this study was done 2013, 2014, basically they consumed about 75 million kilowatt hours per year. Their electrical bill was about $4.7 million a year. Natural gas was about $1.5 million a year. Potable water was about 660,000 a year. So this was really the starting point here. And yeah, even though Louisville Water and MSD are both city enterprises, MSD does have to pay a water bill to Louisville Water. So their total electrical cost was and water and gas was about $6.8 million a year. One of the things that we typically do is develop a chart such as this, and what this chart basically shows across the top in the columns is month per year, and then down the rows is hours per day. And as we know, electric utilities have variable charges depending on time of day and season of the year. So we developed this one for Louisville MSD, and you can see here there was not, in their case, there was not a lot of variability. It ranged from about 4.2 up to 5.75 cents a kilowatt hour. So whereas for other utilities, this is a tool in the toolbox to say, can we defer operation of something? For example, can we defer washing filters until night as opposed to during the middle of the day on a hot summer day? Doesn't make a whole lot of difference here. Just by comparison, I led an energy audit for the city of Atlanta about 15 years ago now. And you can see here that there was great variability, from anywhere from about 3.5 cents a kilowatt hour up to 16 cents a kilowatt hour in the middle of the day on a hot August. So here it did make sense to take a look at deferring things. For example, they have total nitrogen limits, and by doing nothing more than reprogramming their PLCs to wash their filters in the early morning hours as opposed to during the day, they would save about $50,000 a year. So anyway, that's an important thing to take a look at for any one of these audits. It's also important to understand, as I mentioned, not only how much energy is consumed, but where. And what you see here is a one-line diagram for Louisville MSD's plant. One-line diagram is an electrical schematic, basically, that shows the utility service. And the only thing really to note off of this is the two green boxes in the upper right. That was where they had their submeters. And so what we did was we installed submeters at a number of other locations as shown in purple there, because what we really wanted to do was get a better understanding, as I said, of where and how much energy is being used by process to get real data, to be able to analyze real data. And these are what the submeters look like. We had an electrical contractor install them at 12 strategic locations. We took the data for 8 weeks and measured the things that you see there bulleted on the left: volts, amps, real power, kW, et cetera, et cetera, et cetera. And we actually recommended, and MSD decided that they wanted to keep that level of submetering in. So they actually purchased submeters and installed them as part of their energy management program. So what we found, and this is just presented a little bit differently from the circular graph that I showed you before, but if you look to the left, for the percentage of the total plant electrical load is the height of the columns, and the process areas are delineated by each one of the columns. We had to estimate some of the loads, like for their oxygen gas generation system. But by and large, you can see here that about 76% of their total energy that was consumed in 5 areas, basically. The bio-roughing filter, trickling filter influent pump station that I mentioned, the oxygen batteries where they had their pure ox tanks with mixers on top. The sludge dryers and the process water pumps was another process area. Dewatering centrifuges was another, and then the oxygen, pure ox generation was the other one. So, what this really tells you is here's the areas to really focus on. When you go through and look at a facility, there might be opportunities in the headworks, but we all know bar screens and grit units are, typically very low horsepower, less than 2 or 3. Many times on the mixers and the screens. Same thing with HVAC and lab, et cetera. So we're now going to move into our second polling question, and that is, what is the primary task when starting the development of an energy and water saving study? Is it to hold a kickoff meeting? Is it to prepare the first invoice? Is it to perform benchmarking of existing operations? Or is it to have a team celebration?
Hey, Rich, I enjoy your polling questions. I know which one I would vote for. It's probably not the right answer, though. I do have a question for you, right?
Yes.
One of the questions that we've got for you, what are the primary motivators for utilities to engage in doing these energy management plans?
No, good question. As we've seen with Louisville, it was politically driven, but it was embraced, by management. And we're going to talk a little bit about, getting operations engagement and embracement as well, because that's really where the rubber meets the road. But there's some utilities that when I did one of these for DC Water, they were very, and this was again 12, 13 years ago, very concerned about greenhouse gases. And they wanted to reduce, their greenhouse gas footprint. Sometimes they're driven, by the financial side of utility as well, saying, look, how much money, do we have to spend in order to save annual costs where it makes sense to do that, you know, with a relatively short return period, for example. So those are the three primary ones: political, just being a good neighbor, as DC Water was, you know, or really just looking at the financial side of it and you know, reducing impacts to ratepayers.
And it looks like we have wrapped up our poll. Is that right, Sarah?
Yes, yep, I went ahead and closed it. We had everybody answer who has been answering, so let's look at the results. So most thought it was perform benchmarking of existing operations, but then hold a kickoff meeting was also chosen as an answer.
Yep, and actually, you know, technically, I guess the kickoff meeting would come first, but really, you know, after you get beyond that and you start moving forward, the benchmarking is the one that I had in mind on that. Team celebrations are never a bad thing either, so surprised nobody picked that, but there's plenty of time to celebrate as you go through these projects and you know, start recognizing and realizing savings. So we've talked about task one. Let's talk a little bit about the next task. The next task is developing ECMs and prioritizing them. And again, remember this, ECMs are energy conservation measures. So as part of this task, you know, we identified and developed them, we assessed and prioritized them, we spent time on site. Actually, what I really prefer to do is to spend time, excuse me, in a conference room at the plant, where we can develop ideas, where we can engage staff, where we can go out and look at the facilities as we come up with ideas. And what we typically like to do is at the end of each day is sit down with the plant manager or, you know, and/or his key staff and kind of go through what we're coming up with and sort of run it by them to get their thoughts on it. You know, one of the things that I've learned in having done this is there's a lot of good ideas that, you know, that plant operators have on the front lines that for whatever reason, they don't always get elevated within an organization. And part of our job is to take those and to shine a light on them and to elevate them and make sure that the plant staff, you know, gets the credit for that. That's hugely important. And, you know, throughout the time we spend on site, we do interviews with the staff. And as I mentioned, we do brainstorming as well. So there is a commitment, though, that we make to the plant staff because, quite frankly, you know, it's important that we gain credibility with them, and we don't want to be viewed as somebody who's coming in because management wants to find things wrong with how they operate the plant. That is not what this is about. You know, this is really about collaborating with staff to look for other opportunities to reduce energy and water savings. So as part of that, there's some things that we will do. You know, we will review the relevant data, visit the facilities, conduct interviews. We've talked about that, solicit ideas from staff, develop those ECMs and really present quick win opportunities so that if we see an opportunity for a savings when we're walking through the plan, is we'll talk to the operators about that if it's something that can be done relatively easy, so that they can choose to implement it and start saving energy more quickly. And just you know, an example of that is walking through a pump station a few years ago. The louvers were forced open in the wintertime for the ventilation system in a building that was normally heated. So they were using heat that they didn't necessarily, you know, needed to use. And also at another one of the facilities, the filters on the air intakes were clogged, so they were consuming more energy. And these were things that I'm sure they knew to do, but with everything else that plant operators have to do on a day-to-day basis to keep a plant running, they just slip through the cracks. So when we find those, we bring those forward. There's also things that we commit to them, the plant operators, that we won't do. And again, it's really about building credibility and building a relationship with them that we want to do this together. we say we will not get in your way, at least not much. I mean, if we're not getting in their way, we're not doing our job, we're not walking around the plant. But we will not show up unannounced. We won't blindside operations. So, we won't come up with ideas and take them to management and say, operations just isn't doing their job. They're not doing this. We will always, always, always bring that to the operations side first, and then to talk about how it would get elevated in the organization in the most appropriate way. We won't criticize staff, and we won't jeopardize plant performance. Again, we know you need to meet your NPDES permit requirements consistently. So, as we do the walkthroughs, we ask ourselves a few questions, and this is for a piece of equipment or a system. What would happen if we turned it off? What would happen if we ran it at a lower capacity? What if we found more efficient equipment? What if we optimized the performance across the operating range and not just at a particular point? These are all good questions to ask that can lead to some of the ideas that would end up, on a list of potential ECMs. So for MSD, some of the key information for them, was to develop what is an average electric cost, including demand charges, just to keep the calculation simple, natural gas cost, water cost. And then we met with their financial side and said, there's a few different ways to measure the financial viability of the alternatives that we're going to develop. One of them is a simple payback period. If you spend $5,000 today and you save $1,000 a year, the payback period is 5 years. The other one, and this is the one that the financial officer for MSD chose, is to do a net present value and really take a look at what the savings would be versus what the cost would be over a select return period, which was 20 years in this case, and the user return rate, which turned out to be 5% on theirs. You also look at feasibility. I mean, coming up with ideas is one thing, but they have to be feasible and they have to be able to work. And what's the level of difficulty? And the level of difficulty would help determine, if they are feasible and they do offer a nice savings, is it something the utility would handle itself, or would you put it out, as a separate design contract, and have a consultant and a contractor implement it for you? So as we go through that process, there's basically several categories that ECMs can be in. There's the early action items that I mentioned that can be implemented quickly at no cost. There's maintenance related things, preventative maintenance, for example, side-by-side monitoring at one of the large plants that I did one of these at, they had amp meters on the motors on some 24 return activated sludge pumps, and there were several that were way higher than the others, and so that would tell them that they had a problem and that they would go in and take a look at the motors or the windings or something else was going on, and they were so that they could try to keep those operating reliably and efficiently. There's also things that can be procedural or programmatic that are embedded in an organization's culture, like, in a specification, when does it make sense to use an energy efficient versus a premium efficiency motor? And, is there value in developing an energy dashboard through the SCADA system to be able to look at real-time data? And then lastly, I sort of alluded to capital projects, would be larger projects, more complicated projects that would have modifications, equipment process modifications, or even renewable energy, and there's some utilities that previous speaker talked about grease, that look at grease and using grease to help, in their digestion process to be able to recover more gas, to be able to generate more electricity or convert to natural gas. So as we develop all of these ECMs, we come up with a spreadsheet, basically. I know you can't read this, but it basically has each one of the measures on it and estimates savings in power, savings in cost, estimated cost to implement, etc. And the key factors I've kind of pulled out here so we can read them. annual energy savings, as I mentioned, annual cost, simple payback period. You can see here that 3 of them paid themselves back really quickly in like less than a couple of months. And then, a recommendation and then some comments. And as we went through this process and we would update this and share it with plant operations, we came up with essentially 97 energy and water savings opportunities. The focus really was on those that had low capital cost and quick payback periods, so that the graph that you see to the right there, we were really in the lower left-hand quadrant for that. The operational changes, screwdriver changes I mentioned, or quick wins, we brought those forward as we went through. And basically, as we categorized the ECMs, there were 10 electrical, 2 natural gas related, 2 potable water related, and then there were a couple that we identified that really weren't part of the scope, but we did want to bring those forward to the client for them to consider. So we'll dive into the details quickly, because I know we're probably limited for time, but the priority 1 ECMs that we identified, these are things that could be implemented on a standalone basis. They had sludge diaphragm pumps for their primary sludge, and they were using air at a much higher pressure and then reducing it down than they needed to. So a simple adjustment on the air compressors, reducing them by some, if I remember right, 30, 40 pounds or so, had a very real savings. We looked at system-wide power correction across the board. We looked at replacing I'm just reading a few of these, the burners on the sludge dryers. We looked at optimizing the air to the aerated grit tanks also. These were all things that, could be done sort of standalone. The priority 2 ECMs that we had categorized are things that we said, this looks like a really good idea, but we probably ought to, test it. One of them was in the final clarifiers, the channels to the finals were aerated. It appeared to us that they were being over aerated, which not only, uses electricity, but also tends to break up the flock, as it goes into the finals where you want it to settle. So we suggested a program to look at reducing the amount of air incrementally, looking at the impacts and finding perhaps a better, more efficient place to operate. On their high purity oxygen tanks, they have vertical mixers on these tanks. They're covered, they generate oxygen on site, then they pump it through diffusers into these tanks. And they were running all of the mixers at high speed. And by looking at a process model, we said, we don't think you need to do that. We think you can run some or all of the mixers at low speed and still meet your requirements. And they actually did that when we were out on site, and it proved out. So that saved them a significant amount of money in generation as well as mixing. And then, I mentioned they have the bio towers or the trickling filters. We said, we really don't think you need to have the trickling filters and then have the pure ox system, because you can't turn the pure ox system down far enough to where the benefits of knocking the BOD down and the trickling filters really pays off, and you're pumping the flow into the bio towers all the time. So that was another one that we suggested. They take the bio towers out of service and watch what happens, and they did. So, lastly, the priority 3 ECMs were things that would get incorporated into larger, more complicated capital projects, like converting the DAFs to gravity thickeners. We thought that might be worth looking at. Changing the operation of their HVAC sludge boilers. So let's look at several of these in a little bit more detail, just mostly to give you an example of what the output would look like. So, we had the 1 ECM on optimizing the pure oxygen system operation and reducing the speed. Well, we had, as I mentioned, a process model. DWG, Dan Gay and Associates. Dan is an expert in pure ox. I've worked with him on several projects. When we took a look at this and we confirmed that there were no impacts on DO, the capital cost basically to do this was nothing, and the annual savings was about $264,000 a year as I mentioned, they implemented this when we were on site. So it had no payback period. I mean, it really doesn't get any better than that. Another one that we looked at was reducing potable water reduction. We looked at putting in strainers to be able to take plant water, service water, some of us call it, and be able to use that for processed water. Of course, they chlorinated that water anyway, so that was a good thing. So we looked at different types of strainers, came up with a recommendation. The capital cost to put the strainers in and modify the disinfection system a bit was about $425,000 a year. The savings was about $280,000 a year. So it would pay itself off in a year and a half, which is good. We also looked at biogas storage. They flared a lot of gas. The settings on their digester pressure reducing valves could have been better optimized. The control systems could have been better optimized on the burners. We estimated the capital cost to implement at about $60,000 and the savings at about $118,000. So this would have paid itself off after about 6 months. But as I mentioned, and maybe this study had a little bit to do with it, they decided to move in a completely different direction and use thermal hydrolysis for their digesters. And then the last one I'll touch on is really the additional data collection and real-time use monitoring. We talked a bit about the submeters and the importance of the submeters and then pulling that information into the plant SCADA system. We also recommended that they look at incorporating an energy dashboard so that they could basically see what their energy usage was at any given time. They could do trending to see how they were trending, as they would implement improvements, how they were trending in terms of reducing their energy footprint and also to help them make decisions. There's some equipment, not all, where potentially you could defer starting it and into a time that's a little bit more beneficial from a rate standpoint. Again, less of an impact here because of their rate structure as we had talked about. So, polling question number 3. What does ECM stand for? Remember, I gave you guys at least 2 hints on this. No pressure.
And the potential answers are energy conservation measure. Oh, no, you're fine.
Okay.
Energy continuity management, efficiency conservation measure, and enhancements to conserve money.
And Rich, we do have a question. How did you heat polymer feed water?
Basically by putting in some heat tracing and insulation around it.
Okay, thank you.
Mm-hmm.
Another one, where else have you led energy audits at water and wastewater facilities?
Sure, yeah, and I think maybe this was part of the intro, but yeah, for Harrisburg, Pennsylvania, Capital Region Water, I led one on the water and the wastewater side there. DC Water was another one. City of Atlanta, Georgia, at 3 of their 4 wastewater plants. And then in Aurora, Colorado, of all places, which is actually quite a beautiful place in the foothills of the Rockies, both water and wastewater, and learned how they take water from one side of the mountains, snow capture, and transfer it down to the other side. It was fascinating. Certainly nothing that any of us in the Great Lakes Basin have ever had to think about.
It's a whole other level of engineering, I think.
Yes, it was.
Sarah, how's that poll coming along?
I will go ahead and close it. Looks like everyone has responded. And we have split between a few. Most said energy conservation measure, and then we have a couple for energy continuity management and efficiency conservation measure.
Okay, and actually energy conservation measure is the standard industry term. So nobody said enhancements to conserve money, huh? I guess that was a little corny. Okay, so in summary, then, the ECMs that we had identified, I talked about the different priorities, totaled to about $2 million in potential savings a year. Remember, their bill was about 6.6 million, so not quite, but almost a third. And the payback period on the ECMs that we had recommended was about 1.2 years or 14 months or so, which again was, part of the focus was to find those that could be implemented and start saving money pretty quickly. So path forward. Sorry, a little quick on the trigger here. So as we talk about now developing a report, there's so many reports I think we've all seen that end up sitting on a shelf collecting dust, and that's not really what any of us want. We want them to be a living document. So, as part of what we recommend, it's not only the technical side, the findings and the recommendations for the ECMs, but it's also to talk about organizational barriers, and what can be done to improve the chances of successful implementation. And this is just another way of presenting the steps that I had presented before. The plan development was the gathering of information and comparing it, benchmarking it, spending time in the field, looking at key energy consumers, developing ECMs, and then really successful implementation is really establishing an energy management team and encouraging a discussion of energy awareness. So it doesn't stop with the report, it really starts with the report. It's important to remember that the study is just the beginning of the process, and it produces an energy savings plan, and the savings can't really be realized until the recommendations are implemented, and the implementation will not occur successfully unless the organization buys into it, from the front lines all the way up to management. So looking at it a little bit differently, initiating the study and implementing the recommendations is a multi-step process that starts with the study and developing the plan. By the way, some people call these energy audits. I try to avoid the term audit. I think audit typically conjures up, IRS and tax audits, income audits. Nobody likes that term. As part of the energy savings plan, identifying those early action items that we talked about, implementing the findings in a prioritized fashion. Monitoring and verification is important also, not only to say that we think we're going to save so much energy, but to prove that we actually are. And then continuous improvement, either refining some of the things that got ECMs that got implemented that can be further refined, or adding to the list of priorities and saying, okay, we had 92, we've tackled the first 6, now let's go to the next 6 and then the next 6, because we know we can't implement everything at once. So we have to prioritize, how we attack this. And really, a successful energy program at MSD, at any utility, really integrates a number of different activities, from continuous monitoring that we talked about, after the plan's developed, to publicizing success. We've saved energy. Let's share it with our staff, the utility staff. Let's share it with our stakeholders. And you need a champion for the energy savings team. I like to call it the energy czar. Somebody who's going to say, we need to keep energy in the forefront of what we do. Just like we always look at keeping operability in the forefront, we need to keep energy in the forefront and really develop an energy culture in an organization. And every one of the organizations that I've done these studies for has had an energy czar, if you will, that's driven that program. We talked a little bit about, benchmarking, and I didn't really get into this much, but when we started this, for a plant like MSD's plant, the typical range is about 2,000 to 2,500 for a plant of their size and complexity. And when we started the audit, which is I use that word, when we started the study in 2014, they were within that range of about 2156 kilowatt hours consumed per MGD. And they set a goal, and they said by 2019, we want to get down to 1,400. So setting a goal is also an important part of this, and then measuring against that goal and communicating progress against that goal is also important as we think about organizational, cultural changes and organizational awareness. So the last graph that I have, it's a little complicated, so let me explain it. It starts at the left with the legacy facilities and what you have right now and what the current O&M practices are and what you're paying for energy. And then if you jump to the right, where do you want to be? Where do you want to be from a O&M practices standpoint and an optimized facility standpoint? And the things that gets you there is implementing the results of the savings plan. It's developing standard operating procedures to move you along the way. And these are things like, when do we use energy efficient motors? When do we use premium efficiency motors? It probably doesn't make sense to use premium efficient motors all the time, but it doesn't make sense not to use them at all either. So an SOP would define that. And then implementing the capital projects that would come out of the study, in addition to the other recommendations in the study. And all of those things and the organization embracing the change will get you to the fact where you'll have realized success in an energy program. So I'll leave you with something that hopefully puts a smile on your face. This is not what we want, is when the energy management plan is done, having the boss say, I want you to find a bold and innovative way to do everything exactly the same way that it's been done for the last 25 years. Not where we want to be. So anyway, I want to thank you for your time. And I think if there's any questions, if we have time, I'd be happy to answer questions.
Thank you, Rich. That was an excellent presentation. We do have a couple of questions. You had mentioned other places where you've done energy management plans, and are the findings from this energy management plan in Louisville consistent with what you have found elsewhere?
Every plant is unique, and every plant needs to be looked at differently. But as a couple of the graphics showed, that I presented earlier, typically the biological process aeration is a big place to focus on, and that's been consistent as I've done these at other wastewater facilities and pumping the same. On the water side, most of the equipment in a water treatment plant, other than the pumps, is relatively low horsepower. So, typically we'll look at operational changes in a water plant, but we'll also focus on the pumps. Are the pumps operating efficiently? Do they have the right motors on there? And that sort of thing. So at a high level, I would say they are consistent, but every plant has its own nuances. And that spending time with operations and understanding those is hugely important.
Okay, and switching gears a bit from the engineering and operations side, what are some of the cultural barriers that you've had to work through, I guess, at the utility and at the operations level?
Sure. One of them would be, if the head of the utility talked about energy savings, but it wasn't really received by the staff. If you know, they either thought it was something, you know, that was being said for political reasons or otherwise. So I think it's important when a utility, you know, takes this on that and I've seen this, you know, I've seen this happen where the management embraces it and they publicize the fact that this is important and this is something that we need to do. That drives success. And every one of these that I've been involved with, you know, management has said that in different ways, but it's come across to the organization. And you know, but at the front lines is really where things happen. You know, the operators that are, you know, that are running things on each one of the shifts, and you know, gaining their trust is important. And you know, having them know again that, you know, we're not there to try to find fault with what they're doing. We're trying to work together to look for opportunities to benefit the utility and give them the credit for it. And it's just all about, you know, open communication and spending as much time as you know, as makes sense, you know, with the plant staff and at the plant to understand the nuances of and challenges of their facility to make sure that those get addressed properly in the recommendations. Because if it was just a standard list of recommendations that, you know, that somebody would apply from one utility to the other, it's not going to have the credibility. It's not going to get embraced. It's not going to get implemented. So really personalizing it is important for its success.
And you talk a lot about success. Are we talking more on the cultural, the side of things, or are there other more technical aspects that you would also use to define success?
Yeah, I mean, success, you know, numerically, success is saying, you know, our energy bill was this, you know, and now it's a third less. I mean, that's easily measured and quantifiable, and you know, that is a measure of success. But also having the organizational awareness to talk about, you know, in a coffee break room, hey, you know, I was thinking maybe if we did this, you know, we might be able to save some energy or improve the operation and make it more efficient. So it's both really, but you know, it's the numbers, but it's also the organization saying this is important. You know, I see this as important, and I want to be part of it. And you know, the other thing too, I was going to mention this as part of SOPs is in at DC Water, for example. Their energy manager, a gentleman by the name of Ernest Jolly, at the time I did that study, was working to get somebody from the energy group to be part of all of their reviews of design projects. So whenever a project was moving through design and they had a 30 or a 60 or a 90% review, to have somebody there that would be looking at it and saying, you know, is this the most efficient way that we can do this? You know, yeah, we're putting in new blowers, you know, obviously the blowers have to be proven and reliable, but what about efficiency, you know? So having energy have a seat at the table and be recognized throughout the organization for their contribution is important. Did I answer your question? I felt like I might have been, you know, rambling around it a little bit.
Yeah, absolutely. You definitely answered the question.
Okay.
And that was the last question that we have. And I don't see anything additional in the chat box. So I'm going to go ahead and first, Rich, thank you for your presentation, and also hand it back over to Matt.
Yep. Thanks, Kari. Rich, again, like to thank you for presenting on that. It's a really interesting topic that I think hasn't really gotten a lot of attention. I mean, hopefully now that we're starting to be able to look at how we can make these improvements, that it's really something to look forward to here in the future. To wrap up our webinar session here, I'd like to let everyone know about how to submit your contact hours and how we'll be able to go through and approve those. Previously, you were sent the TMACOG. Actually, let me switch over to presenting my screen. So you were sent a contact hour request form with the previous emails, but if you hadn't received that yet, you can actually go to the handouts section on the GoToWebinar little side dashboard there, and you can click and download that form if you hadn't gotten that yet. And to everyone who met the participation requirements that we outlined earlier, we'll be providing contact hours. As mentioned previously, each one of these presentations was eligible for one contact hour of wastewater. The course number information is provided in a follow-up email 1 hour after the end of the webinar, and then also on the next slide I'll be putting forward so that you have that information. TMACOG will also notify attendees of the contact hours via email and will be provided with certificate of attendance. So even if you were not able to, if someone didn't need the operator hours or wasn't able to get the participation scores required to get the official contact hours, there will also be an attendance, a certificate of attendance to have something in addition. We'll also be uploading all the qualified attendees to the OEPA website within 30 days. And also I'd like to mention that there is a survey following the webinar that is mandatory that will help us get all the additional information needed with this webinar training series. I'd like to thank everyone for coming by today. And just so that everyone knows, we do have another 2 sessions coming up. There'll be one at the same time from 12 to 2:30 on Tuesday of next week and Thursday of next week. You can get any of that information you can find out from previous emails that were sent out to be able to see if those topics are of interest to you. And I'd recommend that anyone that has any questions can let me know. Here's my contact information. And again, as I had listed, were the 2 presentations that we had today and their approval numbers. So finally, once again, I'd just like to thank everyone, thank our presenters for coming by and providing all of that incredibly useful information. And thank you to everyone who took the time out of their day to be able to be here for this webinar. Again, if there are any questions, feel free to let me know, and I look forward to seeing people at some of the future webinars we have coming up. Thanks, everyone.